In the second section of 3.4, we're going to go over something called like terms. I want to quickly review what we talked about yesterday, the distributive property, and we kind of went over how to look at minuses as a negative with just numbers, and then we're going to move into the new topic. So if we look at this problem on the left, if I want you to solve this problem or simplify this problem, I want you to remember that yesterday we started talking about the fact that if there's a minus in front of a number, it actually means that that number is negative. You could go through and change each one to addition and take the opposite, but you don't really need to if you share or understand that a minus makes the number of negative because of that process. So when I look at this expression and I want to simplify it, what I'm going to do is I'm going to look for my positives and negatives and simplify those first. So I see that I have a -7, a -4, and a -10. I combine those. -7, -4 is -11. -11 and -10 is -21. And then I look and I have a +6 and a +8, which means it's +14. So now all I have left to simplify is -21 plus 14. I'm adding numbers with different signs, so I subtract, and I have more negatives than positives. And you didn't have to do all that extra movement, all that extra changing signs, because of the understanding that a minus is a negative. So when we look at the problem on the right, I just need you to understand that anytime there's a number outside parentheses or a number multiplied outside parentheses that would be distributed, you have to distribute first before you do anything else. You can't do anything with this 2 minus 4. Well, you could subtract it, but we're going to distribute in this one. You can't combine, let's say, this 4 and this 6 because they're both negative. You can't do that right away because the 4 is inside the parentheses. I kind of like to think of the parentheses as jail. Those numbers inside the jail can't associate with anything outside the jail until the bars are taken away. So by doing the distributive property, you're taking the bars away, essentially. So, like I said, we're going to distribute first. We're going to take +3 times +2, which is +6. +3 times -4, which is -12. And remember, we write negative as a minus. You don't distribute to things outside the parentheses. It's kind of like the 2 and the 4. Here's another kind of scenario. The 2 and the 4 are in the classroom, and 3 is me, the teacher. And I'm handing a worksheet to everyone in the classroom. I'm not going to hand the worksheet to the people outside the classroom. If some random 6th grader's walking by, I'm not going to say, hey, come get this worksheet. So you only distribute to the people in the classroom. So you only go to those. Okay, so I hope I didn't confuse you with that one. Anyways, we're going to move on. So you don't distribute to the next numbers, so you just write them as they are. Now I have an expression just like the last one. I have 2 negatives. I have -6 and -12. Those two together make -18. And I have +6 and +8, which is +14. And then -18 and +14 give you -4. So basically, we're going to take these same ideas and we're going to put variables in it. The variables are what we're going to be able to use to talk about like terms. Okay, so like terms are when you have the exact same variable raised to the exact same power. It does not matter what the coefficient is, because the coefficient is what we're going to be combining, and then the variable will stay exactly the same. Here is an example. If I give you 4x plus 3x, okay, those are like terms. They both have the exact same variable, x, and they're raised to the exact same power. So they don't have a power on it, which means the power is 1. So because they are the exact same thing. We can add them together. It's basically like saying I have 4 x's over here, I have 3 x's over here. When I bring them together, I have 7 x's. The exponent doesn't change, the variable doesn't change, the coefficient is what changes when you combine like terms. People get confused when there is exponents. In my experience, people have gotten confused. So let's say, for example, I have 2x to the third plus x to the third minus 7x to the third. Okay, so these are all like terms because it's x to the third, and x to the third. Exact same variable, exact same power. If this last one was just to the x, these first two would be like terms, and this one would not, because it has to have the exact same power as well. Okay, so I'm going to leave it like this. I think this is a good idea. So I'm going to combine the two like terms that I have. I have 2x to the third and x to the third. Remember, the coefficient in front of that is a 1. So if I'm writing this answer, I have 2 plus 1, which is 3. And then in the past, what I've had people want to make it x to the 6th because they're adding. You have to remember, you don't change the variable when you're combining like terms. So it's x to the third when you're adding and subtracting like terms. So that stays x to the third. And then that minus 7x would just get written right behind it because it's not a like term. Your final answer then is this entire expression. Can't do any more to that. Okay, so let's put numbers, variables, all sorts of stuff together. We're going to do 2 of them together, and then I'm going to give you 2 to do on your own, and I'm going to add another concept to it. Okay, let's start with a very basic expression. 4x plus 2 plus 5x plus 6. You'll notice there are no negatives in this problem, so we don't have to worry about that at all. So I'm looking for like terms. I always look for my variables first. I have positive 4x and positive 5x. Again, notice I always put the sign with the number. So 4x and 5x, those are like terms. When you bring these together, you get 9x. 4 plus 5 is 9, and then you keep that exact same variable. I'm left with a positive 2 and a positive 6. Those are regular numbers. They're constants from what we learned in 3.1, and we can combine those together, and you get plus 8. These you cannot combine because we don't have a variable on the 8, so they're not like terms. Okay, take a second and try this one on your own. This one has negatives in it, so you want to be careful with that. And please notice that there might be more than 2 like terms as you do it. Okay, pause the video, try it out. So again, I'm looking for like terms in this problem. I always look for my variables first, and I notice that I have 3 different terms with x's. I have a negative 6x, I have a positive 2x, and a positive 1x, remembering there's a 1 in front of that number. I can combine these in any order that I want. In my mind, what I'm going to see myself doing is I'm going to say 2x plus 1x is 3x, and then negative 6x plus 3x is negative 3x. So I have negative 3x as the first expression in my problem. I look at what I have left. I have a positive 15 and a negative 7. So positive 15 and negative 7 is positive 8. So I'm going to write plus 8. And those cannot be simplified. In the next example, I am going to add the distributive property to our like term expressions. Okay, let's do this one together and then have you do one on your own. Remember, what I said is if you have anything with distributing in it, you need to make sure that you distribute first before you combine any like terms. So I see that I have a positive 3. It's important to notice that because there's a plus in front of it. I have a positive 3 that's going to be distributed to the two numbers in the parentheses. So let's do that. I'm going to take positive 3 times x, and I'm going to back up 1 second. I'm really sorry. This 2x outside of the problem is in front, therefore it's going to stay in front of the problem. So I'm going to actually write that 2x first right here, and then I'm going to go through and remember that I'm distributing. So I'm distributing positive 3 to x, which is positive 3x. And then I'm distributing positive 3 to negative 2w, which is negative 6w. And then I don't distribute to the last number because it's outside the parentheses. So I would do plus, and I'm going to write that 1 in there, 1w. Now in this one you see that you have two sets of like terms that you can combine. You have a positive 2x and a positive 3x. Positive 2x and positive 3x is 5x. And then you also have negative 6w and positive 1w. Negative 6 and positive 1 is negative 5w. All right, try this next one on your own. See how you do. We have 4 times 2x plus 1 minus 6 minus 7x. Try it out. All right, let's see how we did. We're going to distribute first because that's in the problem. I'm going to take 4 times 2x, positive 4 times positive 2x, which gives us 8x, and positive 4 times positive 1, which is positive 4. The other two numbers then, they are minus 6 minus 7x. They are not in the parentheses, so they do not get distributed to. I look for like terms first. I see a positive 8x and a negative 7x. Positive 8 and negative 7 is 1x, which I'm going to write as just x because we don't have to write the 1 in front of the expression. And then I have positive 4 and negative 6. Positive 4 and negative 6 is negative 2. So my final answer is x minus 2. Okay, there's one more thing that I think is really important to understand, and that is the idea of distributing a negative. In my experience, I have noticed that people often don't notice that this is happening, so you really want to make sure you're watching the numbers that you're working with. An example of this would be a problem like 6c minus 4 times 2c plus 3. Now what you have to notice, there's distributing in this problem. But the number that you're distributing, because we always look at the sign that's in front of our number, is actually negative 4. So we want to make sure that that's what we're distributing and then writing the plus or minus according to if your answer turns out positive or negative. So just like in a previous problem, this first 6c just sits out here. And what I'm distributing then is negative 4 times 2c. Negative 4 times 2 is negative 8c. And then negative 4 times positive 3, which is negative 12. Now I have an expression just like the other ones I've been solving. I have a positive 6c and a negative 8c. Positive 6 and negative 8 is negative 2c. And then I have this minus 12 just left over. So you write minus 12. And that is your simplified expression. Try this next one on your own. Negative 8w minus 5 times w minus 4 minus 15. Let's see how you do. Okay, So let's take a look at this. I do have distributing in the problem. You see that it's right here. Notice I put the negative or the minus in front of the 5 with that part. I do have something out front that I'm going to rewrite. So I have negative 8w first. I am going to distribute the negative 5w, negative 5 to the w. So negative 5 times w is negative 5w. Negative 5 times negative 4. Again, sorry, there was the bell. Negative 5 times negative 4 is positive 20. And then we have that minus 15 outside of the parentheses. I have two like terms here, negative 8w and negative 5w, which gives me negative 13w. And then I also have positive 20 and negative 15, which gives me positive 5. Okay, so for our very last example, we are going to talk about perimeter. Yesterday, in our distributing lesson, we talked about area, and that was when you had to multiply, so you had to distribute the expression times the other side. In perimeter, we know that you have to add all the sides. So let's say, for example, I am given this shape. This rectangle has two sides, 2x plus, or four sides, but the two sides are 2x plus 1 and x minus 3. Now, if you're asked to find the perimeter of this rectangle, there's two ways you can solve it. So you could just add all four sides together. You could write 2x plus 1 plus 2x plus 1 plus x minus 3 plus x minus 3. And you can simplify all of that together. I have 2x, positive 2x, positive x, and positive x. So 2, 4, 5, 6x. And then I have positive 1, negative 3, and negative 3. So I have a negative 6, and I have a positive 2. So that is minus 4. So the perimeter of the shape is 6x minus 4. The other way you could have done this is if you used the distributive property. If you say that you have 2 2x plus 1s and 2 x minus 3s, then you would end up with distributing and getting 4x plus 2. And then you distribute the second one, and you're distributing a positive 2, notice, positive 2x and negative 6. 2 times negative 3 is negative 6. So I can combine 4x and 2x, positive 4x, positive 2x, that's 6x. And then positive 2 and negative 6. So that's minus 4. Same exact answer, just written two different ways. Now, when you find the expression, oftentimes texts are going to then ask you to plug in a number. It might say, write an expression for the perimeter. This is your expression for the perimeter, 6x minus 4. And then find the perimeter when x equals, and then they'll give you a number. So if I say to you that x equals 5, and you need to find the perimeter when x equals 5, you're going to take that expression, 6x minus 4, and you're going to plug the 5 into that expression. So then it becomes 6 times 5 minus 4 So 30 minus 4 is 26. This is 30 minus 4 or 30 and negative 4. You could look at it two ways. So I know that when x is 5, the perimeter of this shape will be 26. And I used my expression to figure that out. All right, so we are going to try this like term thing out. Good luck, and let me know how you do.